Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Subinda with another video. This is parametric equations of a line in two space or two dimensions. Now, when you are given a parametric equation, how can you come up with a scalar equation? So the previous video we looked at a normal vector, the properties of a normal vector. In this video, we are now continuing. When given a scalar equation which is in the form ax plus by plus c is equal to 0 in that form, this equation in this form is called a scalar equation. Then if we have y is equal to mx plus c, this is an equation in the slope-intercept form. So gradient-intercept form. Slope-intercept form. So you are given a certain parametric equation. Here, the ideal thing is, before we continue, I just wanted you to differentiate. So I want us to come up with an equation like this, and not like that, but like that. Alright. The ideal thing is write it in the form of a vector equation. X, y is equal to 2, 6 plus parameter t to 1. Write the vector equation in this particular form. After writing the vector equation in that form, we now need to know the property of a normal vector. A normal vector is equal to NB. Normal vector is equal to AB in the column vector form, in this column vector form. So, what I'm trying to say, this constant of x is delta A, and the constant of the variable y is delta B there. That is the characteristic of a normal vector. So, how can we do this? It's very easy if you take this approach. So this is the second method. The first method was to use t, but in this video, I think we're going to use both methods. So let's use the normal vector. We have 2, 1 as a direction vector. You multiply by x, y is equal to 0. X, y is the normal vector. So 2x plus y is equal to 0. It means that we are saying, if we take it up there, y is equal to minus 2x, and then the normal vector is equal to, right. So first of all, y is equal to minus 2x means we are doing this. I hope this makes sense. It's like we're dividing over 1. So we are flipping it to become 1, negative 2. It's like we are not getting it the way it is here. We are getting it like this. Like I said in the previous video, these need to swap. The numbers, this letter is constant, these numbers need to swap. So this is the normal vector. And this was the first method for finding a normal vector. Alright, so we have found our normal vector like that. This is our normal vector. Alright, so it means we are saying using the ax plus by plus c is equal to 0, x minus 2y plus c is equal to 0. So the only thing missing from our scalar equation is the value of c. So to find the value of c, we need to get this particular position vector. When we get this position vector, the position vector is always in the form of x comma y. So where there is letter x here, letter y, we substitute the coordinates of the position vector. Alright, someone may have been confused here. This one is the coefficient of x. Now in algebra, we do not write 1. So we can't write 1x, so I just wrote x. It means in place of x here, we're going to get this coordinate 2 minus 2 times the y coordinate is 6 plus c is equal to 0. 2 minus this is 12 plus c is equal to 0. It means that 2 minus 12 is negative 10 plus c is equal to 0. We are saying negative 10 plus c is equal to 0. c is equal to 10. So our c is 10. Therefore, our scalar equation will be in this form. We have x minus 2y plus 10 is equal to 0. This is our scalar equation, and the numbers in front of x and y make the normal vector right there. Due to time, I will not explain finding the scalar equation using t. That was explained in the previous video. Alright, this video summary. We had a parametric equation. We then formed this vector equation with a direction vector here. So this here, these numbers with t represent the direction vector. T times 2 is 2t, t times 1 is t. Normal vector for this, you can flip it and just put a negative for any of the numbers, like that. So even if the negative was here, it will still give you the same values. If you were to use a different direction vector. But let's keep it like that. Alright, or a different normal vector rather. Then we found n by using the dot product, or not the dot product, we said this direction vector times x, y will give us 0. Then we found n like that. We substituted in the scalar equation to find c. C was 10. This is our scalar equation. Thank you so much for watching. This has been Cornelius Binda, and bye-bye.